Hey everybody, this video is for Unit 7, Lesson 2, Investigation 2, the Law of Cosines, or sometimes, as I call it, the cosine rule. Alright, so what is the Law of Cosines? Let's begin with the first Law of Cosines that we saw. C squared equals A squared plus B squared minus 2AB cosine C. So that's the first way that we saw that. And then the second way that we could write that is cosine C equals A squared plus B squared minus C squared over 2AB. Now these two things are exactly the same. All we've done is the equation on the right, we've just solved for C, cosine C from the equation on the left. So we just rearranged the formula. That's all we've basically done. So when we looked at these things, we said, well, what was the first thing that jumped out at you? And a lot of people said that this part here looks like the Pythagorean theorem. And that's right. It basically is the Pythagorean theorem. And then we use this other part to kind of modify that, the minus 2AB cosine C. We use that to modify the Pythagorean theorem. And what else did most people, that jumped out at most people, was the side here and the angle here were opposite sides and angles. So they were kind of that matching pair that we sometimes look for when we do the sine rule. So when we have that, now we can kind of piece together our law of cosines. Now keep in mind, this can work for any angles or sides. So if we were looking for A squared and we had some of the other parts, we could just rearrange this whole thing or substitute our pieces, the different parts of the equations for the different variables. So it's just a matter of rewriting like we did in the investigation. Okay, so and same thing on the right side, the cosine C and little c, they are the opposite sides as well. We don't have the Pythagorean theorem jumping out as much at us here, but we do know that these are the two things that kind of stand out. The rest are A's and B's in there. So when do we use this? We can use the law of cosines basically with any triangle. Now what we usually do is we usually use it with non-right triangles, because when we have right triangles or right angle triangles, we tend to use the basic rules, not rules, but the basic properties of sine, cosine, and tangent. Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. So we generally don't use this with non-right triangles. I'm sorry, we generally don't use this with right triangles. However, you could if you wanted. But its primary focus for us has been with any non-right triangle. Okay, so let's look at this a little bit closer. So let's say we've got this triangle ABC and the sides little a, little b, little c. Now as we kind of compare this to our two different versions of law of cosines, we can see that with the first one we have side A and side B, and we also have cosine C, so we've got this angle. So here we've got two sides and the included angle. So that generally works, so that means we have to have side angle side information to put with a side angle side triangle. So we have to have two sides and the included angle, or the side angle side. Okay. What about the one on the right? The one on the right, everything on the right is small letters. So we've got little a, we've got little c, we've got little b, and we're looking for cosine C. So basically what we have is we have side, side, side. So the one on the right uses side, side, side. The one on the left uses side, angle, side. Alright, so let's look at a couple examples real quick. So first we've got here, it's going to be 50 degrees. And we've got this side is going to be measurement of 8 units. This will be measurement of 12 units. And we're going to look for this side. So we're going to try and find x. Alright, so let's analyze the information that we have. First, we have two sides and an included angle, so that means we're going to have side angle side, so we're going to use the first law of cosines that we have. So x squared is going to equal 8 squared plus 12 squared minus 2 times 8 times 12 times cosine 50 degrees. Alright, so all I did was plug in the values straight from the formula above and the triangle that we have, the given information. So x squared equals. Now, we could go through and calculate each one of these pieces, each one of these parts bit by bit, but we've got a pretty powerful calculator at our hands, generally with us. So you can do this whole thing as one long string in your calculator. And what that will do is that will eliminate any possibility of errors for order of operations or anything like that. So just do that in one big string. That's what we want. We want to see you plugging in the information into the formula, use the calculator, punch it in, get a value, right? So that's what I did here, and I get a value of 84.5848 for x squared. Now, of course, we don't want x squared. We want to know what x is, so we have to take the square root of that value, which is approximately 9.97. And that is our solution for x in this first example. Next example. Let's look at another triangle. We're going to have a measurement of 9 units here, 8 over here, 12 on the bottom, and we're going to look for this angle here, the one between 8 and 12, this x. So what we have, the information that we have given is, we're going to find x. We have our 3 sides, so that means we are going to do side, side, side. We're going to use the example on the right. So we're looking for cosine x is equal to, now make sure you put them in the right spots. We need to have our adjacent sides for a and b. So that'll be 8 squared plus 12 squared minus 9 squared, 9 being the one opposite the angle we have. And then we're going to divide that by 2 times 8 times 12. Again, as we start calculating this, you can punch all of this into your calculator, but because we're doing this big fraction, you have to do one extra step if you're going to do the whole thing in your calculator, and that's to put parentheses around the numerator and parentheses around the denominator. So if you do that and put a division sign in between there and punch all that stuff in there, you'll get the answer straight away. And that answer should be approximately 0.6615. I don't want to know what cosine x is, I want to know what x is. So I'm going to have to take the inverse of cosine of 0.6615, and that will give me an angle measurement of approximately 48.58 degrees. And that is our measurement for x. Okay, so the last thing that we looked at when we were going through the law of cosines, we looked at it very briefly, but it was the area of a triangle. Now, we're used to the area of a triangle being 1/2 base times height. And we're still going to use that, but we're going to use some different values to substitute in for base and height here. So let's look at our triangle. We're going to put a height in here, an imaginary height, because we don't have one for this triangle. We'll label it A, B, and C, and we can even call this our base because it's sitting on that part, so we'll call little b our base. And we've got our 2 other sides, A and C, and then of course the height is h. So since we've been talking about all this stuff with trigonometry, when we first found the law of sines and we went through that whole process in the investigation, we kind of worked with something like this. And we focused on angle C, and we said, well, from angle C we have the height and we have the hypotenuse. So we can say that sine of C is equal to h over a, the height over the hypotenuse. Now, normally we put x and h or a different variables in there, but just keep track of what this represents based on the picture that we have. Right? I'm not doing hypotenuse over adjacent side because look at how the picture is labeled. Right? So I'm doing opposite over hypotenuse. Then when I solve for h, I get h by itself. I get a sine c. So this is h, not hypotenuse. This is the height of that triangle. So now when I plug it back into my other formula for area of the triangle, we know the base is little b. We've already saw that whole base is little b. And our height then is going to be a sine c. So if you have angles and sides of a triangle, or specifically a side angle side, right? Because we've got 2 a and b and sine c, so we've got adjacent sides, or 2 sides and an included angle. So if we have that information, then we can find the area of a triangle as well, without actually having a measurable height. So that's law of cosines and area of a triangle. Hope this helps with your toolkits and review. I will talk to you at the next video. Peace out, people.